Hello everyone, and welcome to another Teaching with Nagobs video. Today we are going to be teaching Nagobs about the heart. I already know she knows so much about the heart because she stole my heart. I know, thanks, don't stop blushing, Nagobs, stop it. But we're going to give her usual glasses so that she can lock in with us. And she's an expert on this. Like she is an expert. You know what? We're gonna give her a stethoscope because she really knows a lot about hearts. A lot about stealing hearts. Anyways, so actually I'm gonna make her stethoscope pink. Oops. So we're gonna give her her nice pink stethoscope. And now let's get into the heart. So the heart, the only reason that we are all alive. Well, it makes sense for me to draw hearts now. Look at that. We're gonna go all out with the hearts because we love the heart and the heart loves us. The heart. So the heart is part of the cardiovascular system. And the cardiovascular system is part of the circulatory system. So there is 3 major components of the circulatory system. So circulatory. I'm gonna make my pencil thinner. Circulatory system. Okay. Circulatory system. So there are 3 big components. Number 1, obviously, the heart. Number 2 is major blood vessels. So major, say B, blood vessels. And then 3 is blood itself. So the 3 major components of the circulatory system are going to be the heart, the major blood vessels, and then the blood. Now there's 2 types of circuits. The cardiovascular system runs on double circulation. And the first circuit is going to be, so circuits. Your first one is going to be your pulmonary circuit. Now, we're going to see the word pulmonary a lot. So, whenever you see the word pulmonary, Nagobs, just know that it has something to do with your lungs. Pulmonary is always about lungs. And that is essentially what pulmonary is. It is blood flow between the heart and the... Okay, not the heart and the heart. The heart and... How do you draw lungs? Good enough. Between your heart and your lungs. And then the second one is your systemic circuit. And this is blood flow between the heart into the body tissues. So pulmonary is between the heart and the lungs, and then the systemic is the heart to the body. So what do you think the blood that's going from the heart to the lungs is gonna be? Is it gonna be oxygenated or deoxygenated? It's going to be deoxygenated blood because the blood is going to pass through the lungs to get oxygenated, and then once it's done from the lungs, it's gonna go back into the heart. And then now we have oxygenated blood that's going to be sent out to all parts of your body. So those are the 2 main circuits, the pulmonary circuits and the systemic circuit. So we're going to look at the external structure of the heart first before we look at the internal. I know this is an internal diagram, but we're going to use it anyways. So your heart is in the thoracic cavity. It's literally like, the heart is very small. And no, it unfortunately doesn't look like this. It looks like this. and it is the size of your fist. So if you close your fist right now, it's going to be that size. So about the size of Nagap's fist. And there's 4 chambers. And chambers are just internal space/cavities that contain blood. It is protected in a connective tissue bag called pericardium. And the nice thing about pericardium is peri literally means going around, and cardium literally means the heart. So it means going around the heart. So it's the bag that the heart is in. And in here, there is pericardial fluid. And there's about 50 milliliters in the heart. And when your heart, like, pumps, it rubs against the pericardium. So this fluid basically just reduces friction and prevents inflammation. I don't remember what the disease is called, but there's a disease for when you don't have enough of that fluid. Therefore, there's inflammation in the heart every time your heart beats. That is very painful. So in this in the heart wall, so we'll just do this is the heart wall. You have 3 layers. Your first layer is going to be your visceral, which is the epicardium. Epicardium, which is made of connective tissue, so it is tough. And this epicardium is basically like on the outside of your heart, so it would be like right out here. So oftentimes we point at the heart, and like what is pointed at the as the pericardium could also be your epicardium. So the second one is going to be your myocardium, and this is made of cardiac muscles, desmosomes, and gap junctions. So all the way back to one of the first videos I made teaching Nogops about the cell junctions. We talked about desmosomes and gap junctions, and these are located in the myocardium. So desmosomes are for flexibility, and then your gap junctions are for communication. And then this third one is going to be your endocardium, which is made of epithelial tissue. So let me put that here. So this is connective tissue. This is muscle, or we're going to say cardiac muscle. And then this is epithelial tissue. So connective, cardiac, muscle tissue, and epithelial tissue. So the epicardium is actually what's in contact with the blood that is coming through. So it's going to be on this very inner layer. Your myocardium is going to be the muscle that pumps the blood. So that's why it's so thick here. We'll talk more about the ventricle, but basically the ventricle, it pumps the blood. That's why the muscle is so thick here, because it pumps it at high pressure. So 3 layers to the heart wall. Epicardium, which is made of connective tissue, and it is this outside part. And then your myocardium, your muscle, and then your endocardium, which is actually what's in contact with the blood that's flowing through. So now we can talk about the internal structure of the heart right here. Let's bring Nogops. I didn't forget you. Bring her here with her stethoscope. And I'm just going to put Nogops right here. She'll have to go over the text, or the text will go over her, whatever. So we talked about chambers earlier. There are 4 chambers in the heart. We have, one really important thing is, if you notice here, you're like, that's not the right and that's not the left. In anatomy, you basically want to look at it as if you have plastered yourself on this wall. So right now, if I put Nogops right here, this would be her right and this would be her left. So that's why this is the right and this is the left. So that's how it is. This is your right atrium, right ventricle, left atrium, left ventricle. They are switched because it is inverted, because you basically plastered yourself right on it. So we have those 4 chambers. They are divided into the right side and the left side by the septum, which keeps blood from mixing. So one side is going to have oxygenated blood, one side is going to have deoxygenated blood. The septum is going to ensure that they don't get mixed. So we're going to start with the atriums. So when we're thinking atriums, think 8, okay? Think that they are eating. They are receiving blood. So atrium receives blood. Let me write the atrium right. Left atrium, right atrium, receive blood. So the atriums are always going to be receiving the blood. They are eating. So atrium, 8, eating. And then we have our ventricles. When you see ventricle, think vent. Vent. So ventricles, so right ventricle, left ventricle, it pumps blood. So the atrium eats it, 8, it receives the blood. The ventrium vents, it pumps the blood. So the atrium eats the blood, the ventrium vents it. The atrium eats the blood, the ventricle vents it. Now, this is the closest that the left atrium and the right ventricle, the right ventricle and the left ventricle are going to be, because they are actually separated. They have very 2 different jobs. The right atrium, so I'm going to do this in blue. The right atrium and the right atrium and the left ventricle the right atrium and the right ventricle are going to be deoxygenated. The left atrium and the left ventricle are going to be oxygenated. Alright, that's the important part. So we're actually just gonna divide it into 2 sides. So you have your left side and your right side. The left side is oxygen rich. So we'll do that in red. Rich. And your right side is oxygen poor. There's no oxygen on the right side. Left side, oxygen rich. Right side, oxygen poor. So your pulmonary circuit. Let's start with the pulmonary circuit. It basically starts with both. We're gonna follow the arrows. So actually, before we do that, let's go through the anatomy of it first. So first you have the veins. So you have your superior vena cava and your inferior vena cava in your pulmonary vein. Now I'm gonna say something really confusing right now, Nagos, but you're gonna have to stay with me. So your veins, they take deoxygenated blood away. I'm gonna do it in caps. Away. No, oh my god. Towards the heart. Your arteries, they bring oxygenated blood away from the heart. So let me do the nicer heart. Okay, hold on. There we go. So your veins are going to bring deoxygenated blood towards the heart. Oops. Towards the heart. And then your arteries are going to bring oxygenated blood away from the heart. So veins, deoxygenated, arteries, oxygenated. Veins towards the heart, arteries away from the heart. Back to our diagram. So, this is a vein. This is a vein. This is a vein. This is an artery. And this is an artery. This is an artery. Okay? So we said that the veins bring deoxygenated blood towards the heart. Correct? That's what the vena cava are doing. So we have our superior vena cava, which is going to be at the top, and our inferior vena cava, which is going to be at the bottom. So the superior vena cava is going to be bringing oxygen poor blood from the top of the body, from the upper body, and then the inferior vena cava is going to be bringing oxygen poor blood from the lower part of your body. And basically, it's going to go into your right atrium. So both of these are going to go right through here, and this is going to get into the right ventricle. We're going to talk more about the cycle in a little bit, so this is going to be very, very brief. So we have our right atrium and our right ventricle. The superior and inferior vena cava brings the blood into here. Then they have to pass through something called the tricuspid valves. Now we have two kinds of valves. So let's do that over here on the side. So, heart valves. We have our atrioventricle valves. I'm so sorry. I'm not writing that. I'm sorry. Atrioventricle valves. And then we have, so two of those. And then we have our semilunar, I'm just going to write SL valves, which we also have two of those. Now, you have the two are going to be your tricuspid and your bicuspid. And then the semilunar ones, they are called the pulmonary one. So we'll just pulmonic valve and the aortic valve. So those are your heart valves. What is the use of these valves? The use of these valves is basically to prevent backflow of the blood. So let's say you are having blood that is oxygenated, that is going up from here. So you have left ventricle oxygenated blood, and you don't want it to backflow into here. That is what these valves are for. So let's go through the valves. So you have your atrioventricle valves, which is a very easy name because they are in between the atrium and the ventricles. So atrium ventricle, here's your valve. Atrium ventricle, here's your valve. So they are AV or atrioventricle valves. The two kinds of atrioventricle valves is the tricuspid valve because it has 3 legs. It's not shown here, but it has like 3 legs. And then your bicuspid, or sometimes called the mitral valve, and it has 2 legs. So atrium ventricle, AV valve, atrium ventricle, AV valve. And then you have your semilunar valve, which is going to be right here and right here. And this is a valve between the arteries and the ventricles. So semilunar, it kind of looks like a moon. So semilunar. And they have 2 names. You have the pulmonary valve, which is going up the pulmonary artery. and then the aortic valve, which is going up the aorta. So pretty simple, easy names. So those are the valves to prevent backflow. Next, we are going to talk about the elephant in the room, which are these two. Now, remember how over here I said veins bring deoxygenated blood and arteries bring oxygenated blood, where I kind of lied. This is where it goes the opposite way. So our pulmonary vein is actually going to be bringing oxygenated blood into the heart. And our pulmonary artery is going to be bringing deoxygenated blood away from the heart. This is the only time where this rule does not apply. But in the rest of the body, veins deoxygenated, arteries oxygenated. Alright, so why this happens is, remember how we have the pulmonary circuit and the systemic circuit? I'm going to explain those now using these arrows. So lock in, Nagos. So we said that the deoxygenated blood comes in from the inferior and vena cava, from your body parts. And it goes from the right atrium into the right ventricle, and then it's pumped up this pulmonary artery. The pulmonary, remember what I said is related to the pulmonary? Your lungs. So your lungs are right here. These are your lungs. They're right around the heart. So this blood is going to go into the lungs. It's going to get oxygenated, and it's going to come back through here. That's why we can't have these bloods mixing, because one is oxygenated, one is deoxygenated. So it goes from the pulmonary artery into the pulmonary vein. So now it went from being deoxygenated to oxygenated. So now we're dealing with the oxygenated side. Oxygenated side. So it's going to go from the left atrium. It's going to go through the AV valve, the bicuspid or mitral valve. And then it's going to get pumped through the aortic valve out into the aorta down here, and this is going to send the oxygenated blood into your body. Now, this system right here, the one that takes the deoxygenated blood into the lungs and oxygenates it, that is the pulmonary circuit. And the system where it takes the oxygenated blood from the lungs and shoots it into the body, that is the systemic circuit. So everything's connecting now, huh? And so that is basically how your heart works. Now, there's a small thing, I'm just going to say it really quick briefly. It's called the coronary circulation, which basically provides oxygen to the heart and removes CO2 from the heart. Because your heart needs, it's basically your heart's heart. Like, your heart still needs circulation. So it consists of these coronary arteries and coronary veins that deliver and collect blood from the heart walls. So where do these blood vessels deliver, like where do they come from? And where do they deliver the blood to? They take it to the branches of the aorta. And then, so the coronary arteries, they take it to the branches of the aorta. So they give the aorta oxygen-rich blood. And then the coronary veins empty into the coronary sinus, which is the right vein in the RA. You can't really see it here, but it's somewhere here. So that's the coronary circulation. Now let's get into the cardiac cycle, which is the really fun part. I'm gonna need Nogops here. Hopefully I can take her. We have some text with us, and she lost half of her stethoscope, but that's okay. Let's try it again. Maybe I can. Yeah. Oh, she lost her stethoscope. That's fine. That's fine. Okay. Oh. Alrighty. So, the cardiac cycle, the fun part. Nogops, you're gonna have to chill down here. I'm gonna give her another stethoscope because she got scammed there, and we're gonna make it much bigger and much nicer. Alrighty. So, she's kind of far. Come here. Alrighty, Nogops. So, the cardiac cycle. My personal favorite. So, this is all of the events that are occurring as blood flows through the heart in a heartbeat. So your heartbeat is 0.8 seconds. So you had a lot of heartbeats happening in this video. And each heartbeat is 0.8 seconds. So we're going to break down those seconds and we're going to see exactly what happens in those seconds. So 2 words that we need to know. So number 1 is diastole, and systole. Diastole is relaxation of the heart wall, and systole is contraction of the heart wall. All right, so diastole, relax the heart wall. Systole, contracts the heart wall. And 1 diastole plus 1 systole equals a heartbeat. So basically, the cardiac cycle is the diastole and systole of the heart wall, which equals 1 heartbeat. So let's start with part 1. So 1 is going to be our atrial and ventricular diastole. Do we remember what diastole means? It means relaxing. So that means that our atrium and ventricles are relaxed. So atrial and ventricular diastole, they are both relaxed. What's happening here is the blood is filling into the atrium and it's filling into the ventricle, which means that in this first stage, the AV valves are open, and the semilunar valves, are they open or are they closed? They are closed, because otherwise it's gonna go up through here. We don't want it to go up through here. So these semilunar valves are closed. We are building pressure. So we're letting all the blood pour in through the atria into the ventricle, and we're building pressure. This one is closed, so it's building that pressure, okay? This usually lasts 0.4 seconds. So I'm going to do 0.4 seconds. And then we move on to atrial systole. So let's go back here. Systole means contract. And what's contracting? Atrial. So our atrium is contracting. So the atria starts contracting to really empty out as much blood as it can into the ventricles. So it's gonna keep empty. It's gonna be squeezing. So it's gonna really be building pressure. You can see the pressure building here. And it's just gonna put as much blood as it can into the ventricles. And this usually is 0.1 seconds. Like, it's very quick. And then finally, our last step is going to be the ventricular systole. So systole means contract, and it's ventricular, so the ventricles are going to contract. So in this specific one, over here, the AV valves are still open, and the semilunar valves are still closed. So it's the same. But in ventricular systole, the AV valve is closed, and the semilunar valve is open. Why? Let's see. So the blood has just emptied out. We close the AV valve to stop more blood from coming in, because now we have to pump it out. We have to pump it either to the lungs or to the body. So this blood, the ventricles are going to contract, and they are going to push the blood out there in high pressure. So it's going to go either to the lungs or to the body. And this is usually 0.3 seconds. So that is the cardiac cycle. It starts with the atriums and the ventricles being relaxed and getting filled up with blood. And then the atrium is going to contract to empty out all of its blood into the ventricles, and then the ventricles are finally going to contract to pump that blood into either the lungs or the body. There's one more system of the heart that we need to know, and that is the cardiac conjunction system, or the electrical nodal system. So this is the really cool system. Let's bring Nogops here. I don't want the heart, I just want Nogops. Yeah, I know the trick. You have to bring like half of her. Oh. Yeah. Played these games before. Come on. Bring her down. Perfect. So, this is our cardiac conduction system, or the electrical nodal system. I'm just going to write that here. Nodal system. So you know when you're like watching a movie or when you're in the hospital and you look at the heart monitor and it's doing this. That's what this is. That is the electric nodal system. So it is basically these specialized nerve cells in the heart wall that generate nerve impulses to initiate the cardiac cycle. So we learned about the cardiac cycle up there. This is what initiates the cardiac cycle. My pen just died, so we're gonna have to do this with no pen. So you see up here, it all starts with the SA node up here. So the SA node is going to generate an impulse, and then atrial excitation begins. So as you see this green SA node, it's connected to the atriums. So this is going to signal for the atrium to contract. Both of the atria are going to contract. And then this impulse is going to move down into this red AV node. So this AV node is going to move down the red AV node, and then it is going to pause for a second to give extra time for the atria to fully contract and fully empty the blood into the ventricles. And then that signal is going to move down the AV bundle right down into the ventricles through the Purkinje fibers, and the Purkinje fibers are going to contract the walls of the ventricles, and it's going to get them to contract and pump blood. So the SA node, or the sinoatrial node, is going to be like the pacemaker. It sets the tempo of the heart at about 60 to 80 beats per minute, and it is found in the wall of the right atrium. And then the AV node, it delays the signals briefly before moving to the lower part of the heart, and this gives time for the atria to fully contract. And that is basically the electric nodal system. So when you see that like little spike in the heart rate, like in the heart monitor, that is your Purkinje fibers signaling for the ventricles to squeeze. And that is the cardiovascular system. How do you feel, Magos? That was pretty nice, pretty easy. And I hope she learned a lot. And I will see you guys later.